last page to get through of in 2.3, right? Okay, and on this page, it talks about the top that it's possible to have what are called repeated zeros if the multiplicity, so the exponent of a zero, is more than 1. Okay, so for instance, here, x plus 2 to the third, x minus 1 to the second. That's what we're talking about, repeated zeros. And the graph is just going to have slightly different behavior at the x-axis here. Okay, so an example here, like this one, could factor down to x times x plus 2 squared. So at x equals negative 2, your behavior would be slightly different. It's still going to touch the x-axis no matter what. But it's a matter of whether does it cross through like normal, or does it touch and go the other way, or what does it do? Okay, so this has to do with multiplicity. Again, we talked about this in Algebra 2 last year because I haven't taught it in Algebra 2 yet, but it's in the current chapter I'm getting ready to teach, or that I'm in the middle of teaching. So the graph sometimes touches instead of crosses. In other words, you know, here's your x-axis. You often think about a graph crossing through, yes? Well, we could also touch the x-axis. And that's what I'm referring to with a touch there. Now, the key is, if the factor has a multiplicity that is even, so if it has an even power, the graph is going to touch. So that's like kind of like the bottom of a parabola. It's going to touch and go back up. If the power on the multiplicity is odd, then the graph will cross through the x-axis like normal. Now, I will say the higher the power, the more the graph flattens out, and I'll try and express that a little bit. Either way, anytime your graph touches that x-axis in any way, shape, or form, touches or crosses through, it is still a zero. It is still a solution. Okay? So, example 6 asks us to do a whole bunch of stuff. State the degree, list the zeros, state the multiplicity of each zero, and whether the graph crosses the x-axis at the corresponding x-intercept. And then it says sketch the graph. Now, we're going to, yes, you can still use a calculator, but we're also going to kind of try and sketch it by hand so we can kind of put all of our information together. Okay, so before you jump to the calculator, stick with me. So let's start with degree. Thoughts on the degree? If we were to multiply this all together, we're not going to, so don't stress there. But if we're going to multiply it all together, highest power is going to become what? X to the fifth, yes? Does that make sense? Why x to the fifth? Because this would become an x to the third lead term. This would become an x to the second lead term. And x to the third times x to the second is x to the fifth. Agreed? And again, as I said, don't stress. We're not multiplying it together. Holy cow, no. This is a lot easier to graph in a factored form. Okay? Now, it asks us to state the zeros. What zeros do we have? -2 and 1. Because where do my zeros come from?
The +2 and the -1.
Yeah, it's setting each of these factors equal to 0, yes? If you take x plus 2 and set it equal to 0, you're going to get x equals -2. If you take x minus 1 and set it equal to 0, you're going to get x equals 1. So I'm going to write this as x equals -2 and x equals 1. Are we okay with it, where those came from? Should be pretty basic, but I also didn't teach yesterday, so I'm kind of thrown off as to where our brains are at. Does that make sense? Okay, so state the degree. List the zeros of the function. State the multiplicity of each zero. Okay, multiplicity. Go back up top somewhere. Yeah, oh, there we go. Well, I'm like, I know the word multiplicity is up here somewhere. Okay, if the power on the factoring, now, they're not going to ask you what's the power on the factor. They're going to ask you what's the multiplicity. So if the power on the factoring or the multiplicity is even and odd. So what is, when x equals -2, what is the multiplicity? Okay, hold the odd thought, but yes. Are we good with, this is where x equals -2. My multiplicity is 3. Are we good there? Okay. And actually what I'm going to do here, multiplicity is 3 there. What about when x equals 1? What's my multiplicity? 2. Multiplicity of 2 because the power is 2. Are we stating enough obvious here? So my multiplicity for x equals -2 is 3. My multiplicity for x equals 1 is 2. Now it said state the multiplicity. We did that. And whether the graph crosses at the x-axis, whether the graph crosses, I guess is how it's stated. So basically I want to know, is the graph going to cross or touch? What do we know about the number 3?
Cross.
It is, let's start with the fact that it is odd, yes?
Yeah.
According to the rules, if the power is odd, the graph will cross the x-axis. So this graph, we know it's going to cross. Where is it going to cross at? No.
No. X equals -2.
X equals -2. Good. We're going to cross at x equals -2. Now, so the multiplicity tells you whether it crosses or touches at that point. What do we know about multiplicity of 2?
It's even.
2 is even, yes? Are we okay with Brody's obvious facts here? Now, what's it say the graph is going to do if the multiplicity is even? It's going to touch.
Teachers, pardon the interruption. We do have students returning now. 9th and 10th grade students are returning back to class. Thank you.
And where's my graph going to touch? At x equals 1. Now, I know you may not physically know what that looks like yet. Give me a moment and we'll get there. Are we good there with the facts? Now, okay, so we talked about whether the graph crosses or touches. Sketch the graph. Before we sketch the graph, let's do one other thing. Y-intercept. Well, 2 other things. Okay, we'll go ahead and do y-intercept while I'm here. I'm just going to... And this is just for helps of sketching the graph. How do I find my y-intercept? Y-intercepts happen when x is 0. So how am I going to find a y-intercept? I'm going to put 0 in for x. What's 0 plus 2?
2.
To the 3rd power.
8.
0 minus 1.
8. 1.
To the 2nd power.
1.
8 times 1?
8.
8. So we have a y-intercept of 8, yes? And that's just helpful information, no? Now, this goes back to what I taught yesterday. We decided the degree was 5. What's my in behavior going to look like with a degree of 5? This is what the video taught you yesterday, I guess I should say.
It's going to be one positive is going to go left is going to go down, right is going to go up.
Okay, so my Algebra 2 or my basic language would say down and up. Because here's the deal. Okay, so the degree, do I want to use that? Yeah. Okay, wait, I don't want to say degree 5 though. We've already stated degree 5. 5 is what? That's what I want to state. 5, the degree of 5 is odd, yes? So, okay, let me kind of, I don't know where you guys are at in this in your brain. If it's an odd powered degree, it's either going to be what? Down and up, or up and down. Think about the x to the third graph. What's your x to the third graph look like? It's opposite directions, yes? As opposed to if it's even, x squared. What does x squared do? It's either up, or down, right? If you flip it upside down. So this is an odd power, so we know it's got to be down and up or up and down. How do I decide whether it's down and up or up and down? If we multiply this out, again, we're not going to. If I multiply this out, I'm going to have a positive or negative x to the fifth term. I'm going to have a positive x to the fifth term, yes? If we're going to end up with a positive x to the fifth, then I'm going to have what I would say is a positive leading coefficient. And since my leading coefficient is positive, that tells me we're going to start down and end up. Now, again, did they ask me for that information? No. However, did they ask me to sketch the graph? Yes. And that helps me to be able to sketch the graph. Does that make sense? Because that's kind of cleaning up something that the video taught you yesterday that I want to make sure we understand. It's important. Okay. And again, I don't know how much you remember it, but you did see that in Algebra 2. Okay.
Excuse this interruption, but Christian Club, this is the last day to sign up for it in Mrs. Almonds. Thank you.
Okay. There's my x-axis. And here's my y-axis. Yes, I'm putting my x-axis low on purpose. Okay. What numbers are going to have to be on my x-axis? We're going to have a negative 2 on there, and we're going to have a 1 on there. So minimum expectation, you're going to have to label negative 2, negative 1, and 1. Well, or, you know, have points for those. Now, how high labeling on the y-axis, we have information. We could label a little bit. How high could I label?
8.
So I'll label up to an 8. Yes, those are more squished together. It's good. Okay. You have a blank slate here. We need to graph it. Now, odd degree positive leading coefficient. We decided that my graph is going to start where? It's going to start down, and it's going to end where? Up. Now, you don't have to put those fully in there yet because it's not exactly how much, you know, but that's the idea. Okay, that's what your brain has to visualize is it's going to start down over here. It's going to end up here when it's up, when it's done. We have zeros at negative 2 and 1. What's that mean?
That they don't. That they touch or cross.
Somehow or another, the graph is touching the x-axis at those points, yes?
Yeah.
Those are points on the x-axis. We also said that there was a y-intercept of 8. So we know our graph is crossing through there. Okay? Are you getting a visual of what this graph is going to look like? Should, hopefully. Now, last piece of information. At x equals negative 2, what's my graph doing? We're going to cross through. So we're going to like cross through like that. Okay? At x equals 1, what's my graph doing? It's touching. Which, okay, you kind of have to, that means it's doing one of two things. It's either doing this or it's doing that.
Yeah, the second one.
The second one, because
It has to go up.
use your surrounding clues, right? So it's going to have to touch and do something like that. Can you graph it? Sketch your graph. Now, okay, pause. At negative 2, I need to mention one thing. At negative 2, my power was 3, yes? A power of 1 is a typical cross through. The higher the power gets, and you'll see this in the graph, the more the graph kind of temporarily flattens at that point. So 3 is a little bit bigger than 1, yes? So when my graph crosses, it's still crossing, it's going to cross and it's going to kind of flatten here before it continues up. Is that kind of like what the x cubed graph does at 0, 0? Actually, exactly like what the x cubed graph does at 0, 0. It's going to kind of flatten out and then continue back up. Now, we know it has to cross the y-axis at 8. Officially, I don't know. Do we know that's the max? We don't really know that's the max. I'm not going to worry about that. I mean, I just know somehow or another, maybe you want to do this and it comes back down through 8. Maybe you just want to make it your max. We don't really know. But it does something like that. Now, if anyone cheat and go ahead and graph it before we got there?
Yeah.
Okay. Let's see how we did.
There. Okay. I already want to see it yet.
Okay. Does that kind of look like what I graphed? Kind of. Okay. In all honesty, it probably looks like my graph does go a little bit higher than 8. But again, this is a sketch, guys. I'm not looking for perfection by any means. I'm looking for, did it cross the x-axis at the right place? Did it touch the x-axis when it should have, as opposed to crossing? You know, is the basic shape of the graph correct? How do we feel about that?
Good.
Questions I should answer. That I kind of pulled in some of the stuff from yesterday too, I hope. That's my goal today. Okay. We're ready for example 7? Okay. Example 7. This is an actual calculator question. Okay, it talks about sometimes you have to look closely to tell what is happening, like by zooming in. I think yesterday in the notes, did you have to use ZBox a couple of times in the notes?
Yeah.
Did we remember ZBox? If not, I'll show it. I'll show you, okay, because I'm going to talk about ZBox on this one. But it asks us, it says zooming to uncover hidden behavior, and asks us to find all real zeros. So when it says real, first of all, it says all. And then when it says real, all that's saying is the ones you can see. The opposite of real, or the other part of real, is imaginary. Can you see the imaginary ones? No. Okay? So you're just finding all. Now, what do I mean real zeros? What are zeros? Zeros are what? Okay? So x-intercepts, right? We're trying to find all real x-intercepts. So, we're not graphing that guy by hand, guys. What are you going to do?
Plug it in.
Put that fun thing in your calculator, everybody. My recommendation is you start off at a zoom 6. Does it ask me to sketch? No. Am I sketching just so you can have something in your notes? Yes.
Yeah.
Okay. Now, everyone got it graphed? Working on it? How many answers am I going to have to this problem?
Probably
Two.
3, 4. I'm thinking 4.
Thinking right.
I've heard 2, 3, and 4 so far.
Well,
Let me zoom in.
Okay, now, and that's, you're not supposed to zoom in yet, but yes, that's the point.
I think.
Is this one
4.
easy to tell by just looking at the graph as is? Debatable. Now, let me ask this. What is the most possible amount of zeros I could have? 4, because why?
X to the 4.
X to the 4th. So at most, I could have 4. Now, I'll be honest. We're either going to have 2 or 4. And this is because I know that zeros occur. They have, if it's imaginary, they have to occur in pairs. I can confirm.
It's
So, okay, so we are going to end up finding 4 once we get in there. Now, and did we remember the one over at the left? Or did we forget about him? Now, okay, how do we find these?
zoom in. Z-box.
Now, and you can zoom in here, or could you go ahead and find this first 0 over here before you zoom in?
Yeah. Oh yeah.
Okay, it looks like it's around -3. I don't remember if it's exactly -3 or not, but, so do we remember how to find zeros?
Yes.
Second count.
Second and calc, and then we're going to find a 0, not an intersect, a 0. Now, it's going to ask you left bound. So I need to get left of this -3-ish number. So I'm going to arrow left. And if you watch your x values, that gives you an idea of where you're at. Ooh. Okay, so at -3.0, I'm below. To go left of it, I need to go above. So I'm going to go one more. Because I think if you go 2, you go off the graph, don't you? This is a tough one. So I'm going to hit enter. That left bound is just barely left of it. That's okay. Now I'm going to enter for right bound. Well, now I'm below it. I'm after we've crossed through it, so we're to the right. I'm going to hit enter. My guess, I can't really get to it, so I'm just going to hit enter again. Okay. So one of your answers, I have my answers to 2 decimal places. -3.099736. Or what is that to 2 decimal places? Officially -3.10. Now, this is a good time for me to ask this question. What is that y value on my screen? I don't know what yours is. It may be different. What is that y value? -6 times 10 to the -12. If yours is different, don't freak out. -6 times 10 to the 12th. What is that basically, guys? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's a whole bunch of .0006. What are they saying that is basically?
0.
That is 0. Anytime your calculator gives you something like that, it is 0, folks. Your brain needs to think, okay, that's 0. Okay, now, for this next place, 100% zoom in. Now, you can zoom in. In my brain, this is an ideal place to use Z-Box. Okay, so if you don't remember Z-Box, follow along. I'm going to go to my zoom menu. I'm going to hit zoom here. And I'm going to go to number 1. And I'm going to hit enter. So Z-Box, I take my cursor wherever I want to set up a corner of a box. So I'm going to set up a corner of a box right there. I'm going to hit enter to lock in the corner of the box. And then I'm going to arrow over. I'm going to go to the diagonal corner of where I want the rest of the box. So go to your diagonal corner. So since I set kind of my top left, I'm going to bottom right, hit enter. And then it'll regraph. Oh, hey, guess what? Do I have 3 more answers to find here? Okay, so that's Z-Box, in case you've forgotten or haven't seen it yet. I love Z-Box because I can zoom in specifically the point of graph I want. Okay, find your next 3 zeros.
What the heck?
You have to do them each individually, right?
Yeah.
So second, calc, go to number 2, 0, left bound. I'm going to go farthest left here. Okay, anywhere past it, all of this is left. Hit enter. Right bound, I just have to go right of where it crosses the x-axis. Hit enter. A guess, if you just have 1 0 in there, you really don't even have to go back to the guess. But I do. We have a 0 at 0.5. Find your next one. Second calc, 0. These two are close together, aren't they? You can zoom in more if you want to, but anywhere over here, I'm left of it, left bound. Anywhere over in here below it, I'm right. 1.13303334, or in other words, 1.13. And you find the other one? So now left of it I'm below, right of it I'm above. Hit enter for your guess. 1.36670022 or 1.37. Okay. So your graph does something like that. And so this is where we had 1, 2, 3, 4 zeros, yes? If you want to put something like that on your paper or in your notes. Negative 3.1, 0.5, 1.13, 1.37. Okay. Questions I need to answer on that one. We were able to graph it, find some zeros, practice Z-box. Okay. Did you figure everything out you needed to figure out, Addie? Okay. Angela, did you figure everything out you need to figure out? Because I don't, you're at a point, I'm not sure what you have and haven't seen on the calculator, so just ask if you haven't seen something, because I don't remember what you were here for and not here for. Okay, guys, one more. Example 8. Okay. We kind of worked through this. I think we worked a little bit on this last year too. We kind of worked through it a little bit in pre-calc as well. Write the cubic function. Now, they're giving us a hint there. What are they hinting when they say cubic function?
The degree of cube.
Yeah, it's going to be an x cubed, yes?
Yeah.
Okay, given the zeros of negative 4, 5, and 2. How can I write a function? It's going to be a cubic function. So it's going to have the highest power of x to the third with zeros of negative 4, 5, and 2.
Anything like those are like in the problem? Like they will be in our equation like HK or something?
Not exactly.
So with those, since a 0 is just when you take the factor and set it equal to 0, can you just flip the sign and then do x either plus or minus that number when you flip the sign?
A 0 of negative 4 comes from what factor? X plus 4, yes? A 0 of negative 4, if we had been solving this, would have come from the factor x plus 4. Where does a 0 of 5 come from?
X minus 5.
A factor of x minus 5. Where does a factor of 2 come from?
X minus 2.
X minus 2. So your function in a factored form is x plus 4 times x minus 5 times x minus 2. Now, do you get to leave it in factored form? No. Okay, and there'll be more important stuff coming along with that. I'm confusing my Algebra 2 brain and my pre-calc brain, so I don't know. In either Algebra 2 and or pre-calc, we talk about imaginary zeros eventually, so I just can't remember if we did that in algebra or if it's a pre-calc thing. Okay, multiply these. How should I multiply, guys? Yeah, and start by probably one pair of parentheses, and then we'll multiply the other end, yes? Okay, so how talented are you guys? Can I do this and not have to do a cleanup step?
Yeah.
X times x is x squared. Outsides, x times negative 5,
Negative 5x.
negative 5x. Insides,
That's plus 4x would be minus x.
negative 5x plus 4x is minus x. And last, 4 times negative 5,
Minus 20.
minus 20. And then don't forget to carry down the x minus 2. So you save yourself a step if you don't have to, if you do that cleanup. Now, on this one, somehow or another distribute. I don't know how your brain works. I know how my brain works. My brain tends to take the x, distribute the x to all three, and then take the negative 2 and distribute the negative 2 to all three. However, could you do each of these 3 times each of those 2? You can do whatever your heart desires. If I multiply the x through, x times x squared, x cubed. X times minus x squared. X times minus 20, minus 20x. Then if I distribute the negative 2 through, negative 2 times x squared, negative 2x squared, negative 2 times negative 2, negative 2 times negative x is plus 2x. Negative 2 times negative 20 is plus 40. Clean up and you're there. I got the first term. It's x cubed.
Minus 3x squared.
Minus what? Did I goof up somewhere?
Yeah, it's just minus 20x. It's,
Yeah, I'm confused too.
I'm just making sure you guys are checking my math.
Yeah, minus, so x cubed minus 3x squared minus 18x plus 40.
Here's the big question. Does it match my answer key? Hey, it matches my answer key. Now, in all honesty, guys, as soon as I went to add my like terms, I knew something wasn't looking right. Because I know how those usually work out. And usually in this scenario, there should be 2x squared terms and 2x terms. And all of a sudden, I had 3x squared terms and 1x term. I knew that probably wasn't right. So I caught myself there. Now, I should have said it Monday. I don't know. This is not a 5-minute homework, guys. Okay, I should have told you to make sure you're starting to work through it. Because this homework is going to take a bit. Keep in mind, we've done 3 days of notes for it, yes? Okay, so you are definitely going to want to spend some time looking at it. Mostly it's evens other than 9 through 12. I think 9 through 12 is a matching section maybe or something, or I don't know. I shouldn't say that without checking for sure. But work through that homework. Come back tomorrow, ready to check it, go over questions, and start into, I don't know, lesson 2.4, probably. Whatever the next lesson is.